Hey, welcome everybody. Microbiomes 2.3, investigating antibiotics. So we've been talking a little bit about antibiotics. We had some discussion in our last lesson, great discussion in some of our classes. And now we're going to learn a little bit more about what antibiotics actually do. We're going to look at some evidence as to what they do and how they affect the human microbiome. So first things first, let's go to our warm-up. Oh, almost. There. There you go. We have two arguments. So we're going to be talking a little bit about argumentation today. We have two examples of arguments, and what you're going to do is you're going to read both arguments, and you're going to decide in your warm-up. Let's look at it in Amplify. Ooh, don't let me get ahead of myself. Almost there, almost there. Which of these arguments is more convincing? So we have argument one and argument two. Now, don't just say, oh, argument one because it's longer. No, really, consider the content of each one, okay? So don't forget to explain which one you think is more convincing and why. Go ahead, do that, come back to me. I'm going to guess most of us chose argument one. Yes, it was longer. However, it was more convincing for a few reasons. It seemed like argument one tried to include more evidence to back up their claim. Hey, evidence claims, we're going to start talking about all of these things right now. So which one did you decide was stronger and why? I'm curious to hear some of your descriptions when we meet together again as a class. Scientists ask questions and make observations. Then when they think they have an idea about how something works, they make an argument to support that idea. Scientific argumentation is the way that scientists communicate, evaluate, and revise their explanations about the natural world. We're going to be arguing for a lot of things throughout this entire year. Almost every single unit, we are going to be arguing a certain point of view. We're going to have decisions to make. We're going to have to back up those decisions with evidence and reasoning. So we are starting off right now for something that we're going to be doing the entire year. And you're going to be doing it the rest of your middle school years in science as well. So there's a process to it. And it starts with a question. And let's talk about this really quick. How do you use argumentation in your everyday life? I'm curious to hear about this when we come back together as a class. So the purpose of scientific argument is to convince others using evidence and reasoning, not just, I don't want to clean my room because I don't feel like it. I don't want to clean my room because I have an assignment that is due in 5 minutes. Therefore, I need to devote my time to getting that assignment turned in, which I can clean my room afterward. You're trying to convince somebody of something. Now, that's kind of a silly example, but how do you use argumentation in your daily life? We'll talk about that when we come back together as a class. There it is. A scientific argument begins with a question. So we have a question, don't we? Why did patient 23 feel sick during week 3? Some of us already have some ideas about that. Hey, here's another question. Why did the plants on one side of the mountain survive while the plants on the other side died? What is the explanation for why so many people became sick in one city? Gosh, doesn't this seem relevant? This was back in 2015, I think, when this was produced. So it begins with a question, but even before that, what does it begin with? An observation, really. You notice something. You notice something and you think, I wonder why that is. I wonder why the wind's blowing this direction, not this direction. I wonder why those ants all go along in a line. I wonder why when I stop watering my plant, it dies. So yeah, the observation leads to a question. Once we have that question, we start to think of a claim, an explanation, an answer to the question. Sometimes before we even get to the claim, we might do some research. We might try to learn a little bit about plants or whatever the thing is that we're studying. So for patient 23, why did patient 23 feel sick during week 3? We might do a little bit of research about why people feel sick who have these particular symptoms. Maybe we come up with something. What we are saying right here in this claim is that patient 23 felt sick during week 3 because he was infected with the C. jejuni bacteria. we saw its presence in week 3, and we didn't see it in week 1. So we're saying, hey, that kind of looks like the culprit there. So scientific argument begins with a question, has a claim that proposes an answer. We think it was C. jejuni. And then evidence. That's what we really need. We need evidence and we need reasoning. A lot of people will just throw the evidence in there and they won't use reasoning at all. Reasoning tells us why your evidence actually matters, why your evidence backs up a claim. So if we were to say, okay, patient 23 felt sick during week 3 because patient 23 showed higher than normal numbers of C. jejuni bacteria. Our evidence is what? They showed higher than normal numbers of C. jejuni bacteria. But the reasoning would be something like C. jejuni bacteria causes food sickness type symptoms in individuals. I don't know, something like that. So don't forget to add the reasoning, because somebody who doesn't know anything about C. jejuni bacteria might be like, okay, so what? But then you throw that part in. Oh, well, this bacteria has been known to cause sickness in people, the same type of symptoms that we saw in patient 23. Oh, okay. Now I get it. Now I understand. A lot of times people forget to throw that reasoning in there. And it really just not discredits the argument, but it doesn't make it as strong. We're going to skip this. We're going to go to our vocabulary. A claim. We said a claim was like an answer to a question. The evidence is the information that is supporting our answer to our question, and then our reasoning ties the evidence to our claim. It says the evidence matters because. So here's what we are going to do. We already did this. Hang on, I'm lost. Is there anything we actually have to do here? I don't think so. Next, forgive me. Evaluating. No, we're good. We're good. So going back to these two arguments, which one had a claim? Which one had evidence? Which one had reasoning? Because that one is going to be the better scientific argument, the more convincing scientific argument. So we're going to look at some claims about, some evidence about antibiotics. First, let's talk about our key concepts. Let's highlight these really quick. A healthy microbiome has various helpful types of bacteria. We talked about how, you have tons and tons, 2 to 5 pounds of microorganisms living in you. And a healthy microbiome like yours, it's going to have lots of different types, various types that are helpful and are helping you. Key concept number 8, an infection of harmful bacteria, however, in the human microbiome can make a person sick. So if all of a sudden you start getting more and more numbers of these harmful bacteria, then you're going to start feeling sick. It upsets the balance of everything. Here's our pie charts we saw in week 1. This is what the healthy gut microbiome looked like. In week 3, sick over the toilet, we saw that, okay, there is a clear difference right here. And that difference, we said, was the presence of C. jejuni bacteria. After week 3, the patient was given antibiotics to treat the infection. We're going to start looking at what did these antibiotics do. So how do antibiotics affect the microbiome? Well, here's a possible claim. They cure the infection by killing all types of bacteria in the body, including the harmful bacteria that cause the infection. There were some great questions that we had today in class. Students were asking, are there antibiotics that can just go after specific types of bacteria? And that was such a great question. Go check that out, please. Research that, if you will, and share what you find. So we've got a bunch of these evidence cards. I attached these in your lesson in Google Classroom. There's a PDF. There's 2 pages of evidence cards. What we're going to do with these, we're going to decide, we're going to read through them, and we're going to decide whether they're relevant or irrelevant. Because just because something says something about microbiomes doesn't necessarily mean it's going to add anything to our argument about how antibiotics affect microorganisms. So when scientists are making an argument, they evaluate evidence to see if it is relevant or irrelevant to the question they're investigating. So here's some examples. Our claim: antibiotics cure infections by killing all types of bacteria in the body, including the harmful bacteria that cause the infections. So here's some evidence. Okay, one patient who used an antibiotic found that the bacterial infection on her arm went away in 5 days. Okay, that sounds kind of relevant to me. Talking about antibiotics, talking about a bacterial infection, and talking about the effects of those antibiotics. Number 2, bacteria can live on rocks. Interesting, but is it relevant? I mean, we're talking about someone's arm, we're not talking about rocks, it doesn't have anything to do with antibiotics. I don't know, it seems kind of irrelevant to me. How about number 3, when people exercise a lot, they usually feel healthier. Well, I mean, we're talking about people's health, but it doesn't have anything to do with microorganisms or antibiotics. So I'd say that's probably irrelevant too. So what you're going to do, it says you and a partner. I know you don't have a partner, but you could call someone up and say, hey, let's do this science thing. You will decide which of these evidence cards you think are relevant and irrelevant. You're sorting them, okay? Which ones do you think have anything to say about our claim and which ones don't? So you're going to, if you had someone with you, discuss it. When you come back to class, when we meet together as a class, I'd love to hear some of your reasoning for why you said it was relevant or irrelevant. I can't say relevant or irrelevant fast, even though I just did. What's going on? Get a haircut, Mr. William. So, hey, look at this one. This is evidence card B. It's a quotation from the Human Microbiome article that we just read. The number of bacteria in the microbiome of one human is millions of times greater than the number of people living on Earth. Fascinating. Is it relevant or is it irrelevant? Well, it's kind of irrelevant, isn't it? It doesn't say anything about antibiotics. Yeah, we got a lot of microorganisms living in our human microbiome, but it doesn't really say anything. So these are some sentence starters you can use. Again, you don't have a partner, but you could use these in thinking about those and whether they are relevant or irrelevant. So please go look at all those cards right now. And if you print them out, you can put like an R or an I on each card to say whether it's relevant or irrelevant. If you don't print them out, you could just make mental notes of, okay, I think this one's relevant, this one's irrelevant. And I think that's, yeah, and then we will discuss. So go do that right now. Go ahead and hit pause and sort your cards. All right, when we meet together again as a class, I will ask you which ones you thought were relevant and which ones were irrelevant. So we're going to go ahead and skip forward. So if something is relevant, it makes for a stronger argument. If someone was trying to convince you about how well antibiotics work, and they're telling you how great bacteria can live on rocks, it's like, well, this has nothing to do with your argument. It almost kind of sounds like you're trying to distract me from what you're trying to say. So it's important only use the relevant stuff. Put the cards back together. Yeah, if we were in class, I suppose. Let's return to patient 23. Let's see how this guy's doing. We gave him antibiotics, okay? This is what was going on. We said, it was pretty sure that this C. jejuni bacteria was what was hurting them. So we treated patient 23 with antibiotics. What do you think is going to happen to patient 23's gut microbiome? We are in activity number 4 right now. This is what we saw, and what's going to happen? What's going to happen? Oh my gosh, look at patient 23's gut microbiome now. We need to respond. What do you notice? How do you think antibiotics affected his microbiome? So consider what it was like before. Oh, look, week 1, week 3, antibiotics, and then week 5. Look at that. That is quite a difference. So respond in Amplify right there, and we will discuss that too. I think some of the differences are quite clear though. So go ahead and pause and do that right now. Last thing is your homework. It's all homework, right? You're going to read an article about somebody who studies the human microbiome. Cool. And find out a little bit about what they do, what their job is, and some of the things that they're involved in. So you will access that in Amplify number 5, activity number 5, your homework. And there is a link right there, Meet a Scientist Who Studies the Human Microbiome. There is a question right here. What do scientists who study the human microbiome hope to achieve? So after you read through the article, make sure you answer that question. And after that, people, we done. See you next time.